If you remember, then we have discussed this diagram in the data link layer discussion. So if you recall, then what we were doing there, we were using this as a source MAC address and this as a destination MAC address, which means that if allies wants to send some packet to R1, then the source MAC address will be of allies and the destination MAC address will be for R1. Similarly, if R1 wants to send some packet to R2, then the source MAC address will be for L5 and for L4, and the destination MAC address will be for L5. But the question is that how this router R1 will get to know the MAC address of R2, right? It knows its own MAC address, but how it will get to know the MAC address of R2? And answer of this question is given by ARP protocol. So see here that suppose that these are the IP addresses of these hosts, or this could be routers or anything. Then this host wants to know the IP address or or the physical address or the MAC address, not the IP address, the physical address or the MAC address for this IP address. Then this host will announce, or it will send some broadcast message to every other host, says that who has this IP address, and whoever is having this IP address, it will say it's me, I have this IP address and this is my MAC address. This is how this host will get to know the MAC address of this host or this router, right? Now see here that it is, if it is looking for some physical address of some IP address, then it will request every of the host. So this request message, this is called request message, which is a broadcast message. Now suppose this IP address belongs to this system B, then this system B will say that see, this IP address belongs to me. So that means like this system B will reply with the physical address saying that now the physical address of me is this. Then this reply message is a unicast address, which means that this reply message will only be sent to the system A, not to all the systems, right? So this is the general layout of ARP protocol. Now let's see the ARP protocol in more detail. ARP has some like this is the ARP packet, which means the ARP header. So ARP has some obviously the fixed structure, which like using which it sends the data. So this is the ARP header. It has source hardware address, sender protocol address. So in case of IP, it has some number. In case of like some other protocol at the network layer, it has some different number. So basically, like depending on the network layer protocol, it has the different numbers. And then it will be having target hardware address or target MAC address. So currently it doesn't know the target hardware address, so it will set all zeros here, right? And it will say that I do not know the target hardware address, so it will send all zeros in this case. And this is target protocol address. So the only field that we are interested in, maybe the source hardware address and target hardware address. So the target hardware address is not filled when it is requesting for the target hardware address, obviously. Then how it can be filled, right? Now see, this ARP protocol is directly encapsulated using the data link layer frame, unlike ICMP. So ICMP gets encapsulated in IP frame or IP packet, but ARP directly gets encapsulated in Ethernet or whatever data link layer protocol you are using. Now there are four cases in which we can use ARP. Case 1 is when the sender is a host and wants to send a packet to another host on the same network. Okay, so suppose there is a network and if this host wants to send the packet to this host and that is within the same network, then it uses the ARP protocol to find this host physical address. Case 2 could be when the sender is a host and wants to send a packet to another host on another network, which means this host wants to send a packet, this is the router, and this wants to send a packet to another host here, right? So what it will do, this host will look its routing table. So every host has its routing table, whether it is a host or router, and it finds the IP address of the next hop or router. In this case, it will be router. So based on the destination address, it will check the routing table, and based on that, it will find the next hop. And since it doesn't know that what is the IP address of the what is the physical address of this router, then it uses the ARP to get the physical address, right? So what are the steps? It first look at its own routing table to find out the IP address of this router itself, because it doesn't know the IP address of this router. It only knows the IP address of this host. See here, this allies knows two things. One is the IP address of its own and IP address of the N8, which means IP address of the final destination. But it doesn't know the IP address of this R1 itself. Now how it will find the IP address of the R1? By looking its own routing table. Once it gets the IP address of the R1, then using the ARP, it will get the physical address of the R1. right? These are the steps. So first it will get the IP address of the this router using its own routing table. Then it will get the physical address of this router, let's suppose R, using its using the ARP protocol. So these are the two cases, and there are two more cases. So we will look about these two more cases after looking at these two cases with the diagram. So for the case one, when both hosts are within the same network, so then what we will be doing? We will be sending some ARP, and I will be using target IP address as the destination IP address, because the destination itself is the next hop for me, right? So I will be using target IP address as a destination IP address. So here in case of target IP address, like I do not need to worry. But in case of case 2, the target IP address is of the router IP address. That's the only difference, right? Earlier the target IP address of the directly host, here the target IP address of the router IP address. Now a host wants to send a packet to another host on the another network, it must be first be delivered to the router. So that's the only difference between two cases, right? Now there could be third case when a sender is a router itself and received datagram is destined for a host in another network, which means this is a router and it wants to send to another network, a host in this network. Then what it will do? It will find, let's suppose this is another network, then it will find the entry of this router IP address in its own routing table. So router will check its own routing table, find the IP address of the next router, which means this router, and use ARP to find the next router's physical address. That's all, right? If the sender is a router and receive datagram is destined for the host in the same network, which means let's suppose this is a router and it has received some packet and it wants to send the packet within the same network, then what it will do? It will directly be using the ARP protocol, so it will not be using the routing table. That's the only difference. So see here, first case is that this router wants to send some packet that is destined for the another network. Now the target IP address will be the IP address of the appropriate router that it can be found using the routing table, right? So a host receives a packet to be sent to the host in another network. So this is the case 3. It must first be delivered to the appropriate router. In case of case 4, we can directly deliver that to the host. Why? I mean, we can directly use the destination address, this destination address as a target IP address. So in this case, the router is basically using the IP address of the host directly. It will not use the routing table. That's the only difference, right? Now ARP request is broadcast and ARP reply is unicast. That is just to repeat that we already know. So let's take one example. A host with IP address this and the physical address this. Another host is having this IP address and this physical address. These two hosts on the same Ethernet network. Okay. Now let's see how the ARP request and reply is behaving. So see here, this is the host that is having this IP address, this physical address, this IP address, this physical address, and this physical address is needed by the system A. So it will create one ARP packet, put that ARP packet in the Ethernet frame. Suppose we are using the Ethernet protocol. So in this ARP packet, there will be source MAC address and destination MAC address. So the destination MAC address will be zeros. See here in the ARP header, if you remember, like you do not need to remember basically this header, but I'm just showing you in this header the source and destination MAC address is there, right? So this will be zeros, this will be zeros. Okay, this will be zeros when we are creating the ARP packet, and this is the source and destination address. So source MAC address, that ARP packet will be formed, and then this will be a request message, and this message is broadcast message. So this entry is showing that this message is broadcast message, which means in the Ethernet frame as a destination address, I will be having all the ones. All the ones as in the physical address shows that it is a broadcast message. Broadcast message. So this is a broadcast message, right? Now this message will be received by everyone, including the system B. Now system B will create its own ARP packet. It will say that this is my source IP address, source physical address. So system B is having this as a source physical address, and it will say that this is the destination physical address, which means now this time it knows that what is the physical address of the destination. So this same physical address, sorry, see here, this AB, right? Yeah, this same physical address will be used as a destination address in the Ethernet frame. So this is Ethernet frame, this is the ARP packet, and this is a destination address in Ethernet, which means this is not a broadcast message, this is a unicast message. So ARP reply will be a unicast message, right? So that's how we are using the ARP to get the physical address of another host.